So in this case, this small a of s is always represents my open loop system. Okay. Transfer function. Okay, so now I'm going to use my capital letter for representing the closed loop transfer function. Okay. Now the point is, I just want to discuss what if I just want to evaluate my capital A of s from here. So I have an open loop system having a single pole, and what would be the value of the closed loop transfer function? Okay, so we know that okay, let us assume it's an inverting stage. Okay, so I use my negative sign here. Okay. So what happens is, like, I can write it as A of s divided by 1 plus beta times that of A of s. Okay. So just because I'm taking a negative sign for my, or in an inverting stage across my A of s. Okay. I just want the final expression to be evaluated. What happens after I plug in this A of s onto this? I think it's a pretty simple expression, right? Okay, I just want to know about the inference of this particular result. What does the result conveys me? This A of s is having some sort of term or expression which looks something like this, right? What is it? Yeah. Okay. Yeah, so I have this particular part. What is this quantity is basically? It's a DC gain of my closed loop system. Whereas, what is the DC gain of my open loop system? Yeah. So I had a similar term that was sitting at the top where no S factor sits over there, right? So a similar expression happens to be here. Okay. So it's the DC gain of closed loop system, whereas this is the DC gain of the open loop system. Okay. Where is my pole? So it says that the pole is located at P1, right? That is the frequency at which I have my pole of the open loop system. But what happens here? Which is my term? Okay, so what is the inference of these two things? What has happened to my magnitude? First of all, when I move from open loop to the closed loop, okay, yeah. So now, what I'm going to do is I'm just going to map my closed loop transfer function onto the same graphs. Okay, so I'll use this pink. And now, what has happened to my DC gain of my closed loop? Was it higher than what I had before, or is it lower? Yeah, it's supposed to be lower. So what I have here is something like 20 log of k divided by 1 plus beta times that of k. Okay. Now this value is obviously smaller than the value of k itself. So I have something like this. And where is my pole? The pole of my closed loop system. What is the value of it? This is the location, right? So it has actually been pushed somewhere over here, and the new value of this pole is shifted here. Okay, and now what has happened is, like when I try to draw the magnitude plot, I all the way go here, and after this I start following this minus 20 dB per dk. Okay, and this is what is happening to my closed loop magnitude plot. But what about my phase plot? Is it really difficult to answer? You see, this is the pole location of my closed loop system. Okay. Now similarly, I will also have a pole at the same spot, right? So this is my new pole that I have here, and due to which we know that till I reach to 0.1 times of whatever the value that I had, I will have a 0 degree phase shift. And after a while, when I reach to this particular spot, I need to have 45 degree. And then when I go a decade away from this location, I reach a maximum of 90 degree. Okay, so there is a shift in my phase, okay, to a different frequency. Is that all clear? Any doubt in this? Okay. Now what is the inference that we can take home from here? So when I put a closed loop system, what has happened to my gain? The gain got reduced, but what happens to my bandwidth of my system? Increased. Okay, so by whatever factor the gain has got reduced, but the same factor the bandwidth has got increased. Okay, so in the next class we will talk about what for stability analysis. It's not only we have this Bode plot, we also have something known as root locus. Have you learned about it? Okay, yeah. So we'll talk about this root locus just for a minimum requirement, but majorly we will focus on the Bode plot for us to analyze the stability of my system. Clear?